Welcome to Bravel Institute. Today we are discussing about kaplan meier model. This model is for survival analysis. So Edward Kaplan and Paul Meier have done some observation, have done some experiment and find out how to estimate the survival probability. So it is very simple method and only observation we can find out the survival probability. For that I am taking small example. This is my house. This is my house, small house. In my small house I have a 6 puppies. I have a 6 puppies. So it is a small observation I am performing for the understanding the kaplan model. This is number 1, this is number 2, this is number 3, 4, 5, 6. So I have a 6 puppies in my house. They are happily living in my house. There is no issues. But after some time, my all puppies, these all puppies is affected by COVID. So I understood it is a COVID. I want to give medicine. So I given medicine. I given drugs to all the puppies. So vaccine is given to all the puppies to cure the COVID. So after giving drugs or medicine or vaccination, I am doing my observation. So my observation is start from the after giving this medicine. So I am checking, I am analyzing what is the survival and what is the effectiveness of my drugs or patients living after the treatment. So these all are including for this observation analysis. So for that I am taking my observation only in 7 days. My observation period is 7 days. My observation period is 7 days. Why after 7 days I'm not taking any observation? So I cut my observation up to 7 days. So 1 week of observation. So I can say in my observation I right censored. I can say it is right censored. Right censored. Why? My observation is only for 7 days. So my observation is right censored. So in kaplan meier model is explained one assumption, it is a right censored observation. So it is so up to 7 days I am observing only up to 7 days. So I already given medicine. In first day I given medicine, there is nothing is there. So this is my timeline. So I can say this line is my timeline for 7 days observation. So I given is a time tj. Nj is number of puppies on this time available. That is nj. I'm taking hazard rate. Sometime this you can say lambda j. Sometimes some puppies will die. So I'm taking hazard rate and survival rate. Survival. This is 1 minus lambda j. Both I am writing here. So in my observation is started in first day. First day I checked in my house. This is my house. My observation in my house. I checked, nothing is happened. All are very happily living. My puppies, nothing is happened for my puppies. So in this day, first day, 6 puppies are living. Nothing is happened. So 6 puppies are living. So I not taken any hazard rate or survival rate because my survival rate is 1. Because no puppies, everybody is living. So my observation in second day, I checked in my second day. These are days. My second day, I understood one puppy is died. This puppy is died. So I taking out this puppy is died. So third puppy is died. Taking out. This one is third die. Third puppies. So second day understood one puppy is died. So I taken out from my house, taken out to outside. So what happened? Initially, how many is there? Initially, in my observation, 6 puppies are there. Here, one puppy is died. So what will be my hazard rate? So out of 6, one is died. And what will be my survival rate? Out of 6, 5 is survived. So my hazard rate is 1 divided by 6. How you got 1 divided by 6? 1 is died. Out of 6, 1 is died. My survival rate is 5 by 6. Why? 5 is still surviving. 1 is died. My survival rate is 5 by 6. So I written my hazard rate and survival rate. Number of puppies are 6. So this is getting from my observation and not taking any parameter. So we can say Kaplan-Meier model is a non-parametric model because not taking any parameter, just observation and values is taken out. So 1 by 6 and 5 by 6. In third day, again I observed in my house, then I understood this puppy, so this puppy is gone. This puppy is died, I taken out. My third day, I understood. My third day, for me, 5 puppies are there. For me, how many puppies are there? 5 puppies are there. Third day, 1 puppy is left out. This puppy, second puppy, has come out from my house and jumped and escaped from my house. So this second puppy is escaped from my house. So this one is not died, but it is jumped and escaped from my house. And I don't have any information about this puppy. So this puppy, second one, came here. Second one is came outside. Came from my house and went outside anywhere else. So it is escaped from my observation or it is jumped from my house. So I don't have any information about these puppies. It is left out. So this observation, I can say it is a non-informative. I can say non-informative. Because I'm not analyzing what happened for these puppies. I'm not tracing these puppies. These puppies is left out. So for me in third day, 5 puppies are there. One puppy censored. I can say I censored 1 puppies. I am removing from my observation because it is escaped. So I removed from my observation. So for me, how many puppies are there in fourth day? Fourth day, I have 4 puppies. In fourth day, I have 4 puppies only. Third day, there is no hazard rate or survival rate because it is escaped. It is not died, so it is escaped from the house. So in my fourth day, again I checked in my house what happened. These puppies, whether it all are living or anybody is died. So I understood 6th puppy, this puppy is died. So I taken out this puppy. 6th puppy I taken out. 6th one is died. So out of 4, 1 is died, so 1 divided by 4. Out of 4, 1 2 3 4, 1 is died, so my hazard rate is 1 die, 1 divided by 4. What is my survival rate? Out of 4, 3 is surviving, this one is surviving, this one is surviving, this one is surviving, so I can write it is a 3 by 4. This is my survival rate, 3 by 4. So I am removing this puppy. This is already taken out to here. So in my observation, how many puppies are there in 5th day? 5th day I have only 3 puppies. I have only 3 puppies in 6th day. 5th day. In 5th day, what happened? Again one puppy is jumped from my house. It is jumped. This is my compound wall. It is jumped. So it is gone outside again. One more puppy is gone outside. This puppy is gone outside. It is when escaped from my observation. So here it is. One more I censored. It is jumped from my observation. So it is a non-informative censoring. It is went outside, anywhere else they can live. So in my observation again one is gone. My 6th day, I understood one more puppy is died. This puppy is died. Number 1 is died. I taken out. So 6th day one more puppy is died. So what will be my number of puppies are there? Only 2 puppies are there. Number of 2. And what is my hazard rate? My hazard rate is 1 by 2. Out of 2, 1 is died. What will be my survival rate? My survival rate is 1 by 2. My hazard rate is 1 by 2 because out of 2, 1 is died. What is my survival rate? That is same. It is a 1 by 2. Out of 2, 1 is survival. So I removed this one also. In my 7th day, nothing is happened. This puppy is living. I stopped my observation in on 7th day. So in kaplan model, it is a right censored, non-informative model. We don't have any information about escape, what are the puppies are escaped, and it is a right censored. We end of the my observation on 7th day. 8th day may it will die, may this puppy will die, but my observation is ended on 7th day. So these are the my observation. I not taken any parameter from outside. So it is, we can say kaplan model is a non-parametric model. These values is taken from my observation. These are the values I am taking to my drawing one table. This is one table for understanding the values. Is a tj and it is a dj, is a nj, is a lambda j. This is equal to dj divided by nj. This will understand. Hazard rate is 1 by 6. So 1 is died out of 6. We can say it is a dj divided by nj. 1 is died out of number of puppies available. Nj is equal to 6. 1 is died. Here also you can say it is a dj divided by nj. So same is dj divided by nj. And one more term, survival 1 minus lambda j. It is estimated. This lambda j is estimated, so I giving cap. This is estimated from the my observation. So these are the table. I am adding one more term. This is product of k is equal to 1 to j 1 minus lambda j. Product of 1 minus lambda j. What are the values is getting here? I have to give multiply that value. So it is a product of 1 minus lambda j. So Kaplan-Meier equation, I can say survival rate, survival probability st is equal to, what is my survival probability? St is equal to, this is the my equation, tj less than or equal to t 1 minus lambda j. Lambda is observed value. So in my observation, if you multiply by survival probability, we will get the survival probability of each time. So this is the my survival probability. This is my equation. Kaplan-Meier equation, survival probability is equal to product of tj less than or equal to t 1 minus lambda j. Tj is a time up to each time where is a death is happened. In here I will take only survival analysis only on death time, where is a death. So say second day there is a death, fourth day is a death is happened, sixth day is a death is happened. I will take only these values only, because I am calculating the hazard rate. Hazardness is happened on this days only, 2 4 6. So in those days only death is happened. I should not take a censored time. So 2 4 6, and I know how many deaths is happened. In second day only one death, and fourth day one more death, and sixth day one more death. So I know the value of dj. I know the value of nj is already written. In second day it is a 6, and fourth day it is 4, and sixth day it is. So I know this value of nj. Nj is number of puppies are alive at the time of observation. At the time of observation, how many puppies are alive? So in this time 6 puppies are there, and here 4 puppies are alive, here 2 puppies are alive. That is nj. Lambda j I know it is a 1 by 6 and 1 by 4 and 1 by 2. So dj by nj already I got it. Lambda j 1 by 6, 1 by 4, 1 by 2. I return 1 by 6, 1 by 4, 1 by 2. 1 minus lambda j is also value already I written. This is each survival probabilities 1 by 2. Here product of the 1 minus lambda j. So my 5 by 6 is here, I taken 5 by 6. There is no need to multiply anything. How to get a second time? Second time I have to multiply 5 by 6 into 3 by 4 is equal to some product of the 1 minus lambda j. So first term has to multiply the second term. So I got 5 divided by 8. And what will be third term? We have to multiply the 3. First one 5 by 6. Second we have to multiply 5 by 6 into 3 by 4. Third we have to multiply 5 by 6 into 3 by 4 into 1 by 2. So I taking 5 by 8 into 1 by 2 is equal to 5 by 16. So these are the values. This is my survival probability values. This is the Kaplan-Meier equation, and equation I got from the my observation. I feel you understood about the how to write the timeline graph and number of j, hazard rate, survival rate. After writing each term, I have to draw the table. 1 1 1 dj. Tj time will take only at the time of death, and nj how many are alive at the time of observation. Lambda j is equal to dj by nj, and 1 minus lambda j is a survival rate, and survival probability we have to multiply each term. Now I am going to write the survival formula ST. How to write the ST? At the time of 2, my survival probability is 5 by 6. So up to time 2, here it is there, 6 is there, and death is there. One. So up to the time 2, there is all are alive. Up to the time 2, all are alive. So my survival probability is 1. 0 less than or equal to t less than 2. Up to the time 2, my survival probability is 1 because all are alive. 2 to 4, my survival probability is 5 by 6. So this is the 5 by 6 is my survival probability. 2 to 4 less than 4. Up to 4, my survival probability is 5 by 6. And 4 to 6, my survival probability is 5 by 8. So 5 by 8. 4 less than or equal to t less than 6. 4 to 6, my survival probability is 5 by 8. And 6 to 7, up to 7 I observed 6 to 7, my rate is 5 by 16. 5 by 16. 6 less than or equal to t less than 7. Up to 7, my rate is 5 by 16. So these are the survival probability we received from my table ST. We can write FT. We can write same like we can write FT as a distribution function. Distribution function, how to write the distribution function is always 1 minus ST. So distribution function is equal to FD is equal to 1 minus ST. So what is the values? Is a 0 up to time 2 value 0 1 minus ST, and up to 4 what will be 1 minus 5 by 6. It's a 1 minus 5 by 6. What is the value of 1 minus 5 by 6? So 1 by 6. 2 less than or equal to t less than equal to 4. 1 minus 5 by 8. So it will get a 3 by 8. Here it is 3 by 8. 4 less than or equal to t less than 6. This 1 minus 5 by 16. What is a 1 minus 5 by 16? You will get 11 divided by 16. 6 less than or equal to t less than 7. So this is the my distribution function. How to get a distribution function? It is a 1 minus st. 1 minus 0, it is a 0. 5 by 6, 1 minus 5 by 6 is equal to 1 by 6. And 1 minus 5 by 8 is equal to 3 by 8. 1 minus 5 by 16 is equal to 11 by 16. This is my distribution function is writing from survival probability. Now I am making diagram how to give these values in diagram, representing in diagram. So removing this timeline graph. Now ST is a product of 1 minus lambda j. So it is a product of 1 minus lambda j. 1 minus lambda j is the 5 by 6. It is a survival probability. So probabilities 5 by 6, 3 by 4 and 1 by 2. We multiplied each term. 5 by 6 into 3 by 4 we got 5 by 8. 5 by 6 into 3 by 4 into 1 by 2 we got 5 by 16. So this kaplan estimate also called product limit estimate. It is also called product limit estimate. This actually it is a survival function. St is a survival function. We have to represent like that. It is estimating from the 1 minus lambda j. It is a survival function. This one is distribution function. We have to represent like that. It is a distribution function. So survival function is getting from product of the multiplying each survival probability in each time, 5 by 6, 3 by 4, like that. We multiplied from each survival probability, we got the survival function. So it is multiplying each probability, so it is called product limit estimation. Now we are going to represent in graphical representation, how to draw the graph. Our time is start from 0, 1, 2, 3, 4, 5, 6, 7. So it is x-axis is time and our y-axis 0.2, 0.4, 0.6, 0.8, so 1. It is a survival probability, survival function. Here also a small correction is there. We have, it is a survival function. We have to represent like that only. It is estimating, getting estimation is getting from 1 minus s of t. So how to draw the graph? The survival value, survival probability values are available. How to draw the graph? So for me, 0 to 2, my time is, my probability is 1. So it is my probability, it is 1, 0 to 2. Up to 2, my probability is 1. So it is 1, my probability is 1. So we have written, we have drawn the first probability 1, 0 to time up to 2. And 2 to 4, my 5 by 6. 5 by 6 is the 0.83. So it is 0.83. It will come around approximately here. So I draw, it is from here 2 to 4. So it will come up to here. So it is 0.83. It is approximate value by 5 by 6. And next is 4 to 6. 4 to 6 is 5 by 8. My value is 4 to 6 is 5 by 8. 5 by 8 will get 0.62. Approximately 0.62. So my 0.6 is here. So I will get here. So it is here up to 0.6. 2.6. So this is 0.62. 6 to 7. 6 to 7 is 5 divided by 16. You will get approximate 3.1.31 is 2. So my point will get here 0.31. So this is my graphical representation. Survival function is represented survival probability 0, 0.2, 0.4, 6, 8, 0.8, 1. 1 is getting from up to 0 to 2, my probability is 1. And 2 to 4, my probability is 0.83. 4 to 6, it is 0.62. 6 to 7, it is 0.31. So this is my graphical representation of survival function. So Kaplan-Meier, any doubts about this Kaplan-Meier estimation, can you visit www.bravelinstitute.com and send me mail in bravelinstitute@gmail.com.